Today I'm going to present you, in this case, some of the work that we have been developed inside of the university in our research group. And this is called Self-Sovereign Identity and Trust Infrastructure for Secure Agentic AI in Data Spaces. So I wanted to introduce more or less the outline that we have today, and I want to give you some context and motivation about this work. Then I want to talk to you about, in a very brief way, about self-sovereign identity, authentication, and authorization, in this case in the context of data spaces. That is all of the work that we have been developed in our research group. Also, I'm going to give some pointers to how we can integrate all of the part of the trust in the agentic AI in the context of data spaces, and finally, some conclusions and future work. Well, a little of a presentation about our research group. We are a research group of the Technical University of Madrid. We are working in many research aspects like LLMs, distributed data, open data, data spaces, data engineering, big data, and many other things that we have been collaborating with many enterprises and also with the academia in these topics. This presentation was made by me and my colleague, Professor Joaquin Salvatierra, that presented before all of the aspects regarding data spaces and some of called the data space definition language for providing some of automation in this type of ecosystem. All of this project is called Eunomia. Eunomia is the God of law and legislation. Is a Greek God that represents all of the things that we have been developed inside of this project. We have some topics that we cover with this, like evolution of transport protocols, also self-sovereign identity, also LLMs, and many other things that we have like objectives in this topic. For starting with the presentation, I want to introduce the concept of data spaces. This is a concept that was made in a standardization group in Spain. So this is an standardized definition of data space. And a data space is defined as a collaborative ecosystem that enables diverse entities to share, use data, and deliver service in a secure, trusted, and compliant manner. This is different from the world of open data because the aim here is promote the data economy, that the companies can not only share the data or public the data in an open way, but also share the data giving some, in this case, monetize this type of data and also the services that uses this data, but with all the legislation and the governance of all of this ecosystem. This is the easy definition, but we have the technical definition. And in the technical definition, data space is called as a federated open infrastructure for sovereign data sharing based on common policies and standards. This is more technical, and if you put attention in the bold words, we have many complex things that we have to face it in this type of ecosystem. Federation is not a centralized ecosystem. Sovereign for giving the owner of the data all of the rights over this data. Policies, because we need to define what we are allowing to other people or other entities, what they can do about the data that I am publishing. And also standards, because we have to talk in the same language, in this case, for sharing the data. In the technical part, we have in the data spaces many building blocks. We have the business building blocks, that is, in this case, the right column in the color more or less red, and all the technological blocks that are focusing in data interoperability, all of the part of semantics, data exchange, data models, data sovereignty and trust, that is where we build all of the part of the identity that is regarding all of this topic, And also trusted exchange, and two things that we need to include that are access control and data usage control. That is a complex problem that we are trying to, in this case, make some research about this topic. Finally, we have the value creation that is regarding all of the platforms that are needed to publish and sell the data or the services that we are publishing inside of the data spaces. In this talk, I am going to center more or less in the part of the data sovereignty, that is regarding all of the part of authorization and authentication in case of data spaces, and how we can join this with the agentic AI ecosystem. In a data space, we have a diverse transfer protocols. So a typical scenario, or the more simplified scenario, is when we have only two actors, but this could scale in many actors sharing data. But for a simplified way of presenting this, I have two actors in where one could be a provider and the other could be a consumer. And we have to have in this topic many different things that we have to consider for start to sharing data. We have to know how we are going to move the data from one side to another. We have to know who are requesting this data, and also what are the policies that are applied to this data. You can use this data, but you cannot copy or you cannot share with anyone. Also, we have a contract that we have defined in an automatic way for providing this type of services. All of these things need to be faced with different standards and with different type of standardizations. In this case, in the data spaces, all of the participants are agreed to use DCAT for the metadata, like we usually use in this case in open data portals. But for the part of the transference, we need to define how we want to move or provide the services between these participants. So in the transfer scenarios, we have the two typical scenarios. We have the batch data, the historical data that is stored in some place, and also we have the most difficult, in some way, a scenario that is the streaming. Okay? This is very important in the cases of the smart cities. The smart cities, you can catch and use the data more or less in real time, soft real time. So in this case, we have to consider these two scenarios, and for these two scenarios, you have to identify that you have two different ways to interact with this type of data. If you want to use historical data, you have to query to this data and retrieve some data. But in the case of streaming, you have to open in some way a channel for moving the data from one side to another side. But it's not the only thing that we have to consider, because if we are talking about data spaces and data scenarios, we have to know that the data could be very big. So in this case, that is why we have to consider how we can move this data from one side to another in an efficient way. For this, for achieve this, we have, in this case, present some of the solutions that will be based in some big data tools for moving the data from one side to another. Tools like Apache Flink, if you want to work in real time, Apache Sparks, if you want to perform some data processing in a fast way for a very big block of data. And also, we have to know that we have to use different protocols to move the things in more efficient way and with a more modern type of transfer, like in this case is the QUIC protocol. And one question that you may have in your mind is why or how we can define all of these things to start to transfer. Well, all of this part is more or less regarded to the definition that the services that you want to use. And this is linked to the presentation that Professor Salvatierra told yesterday about how we can define all of these things in an easy way using a definition language. So with this definition language, you only need to declare what you want to do, and the system is able to start all of the things necessary to start these transfers and all of these protocols. All of this is more or less a context about data spaces, and right now I wanted to enter to the part of the authentication in data spaces. In data spaces, because we are talking about a decentralized ecosystem, we need to integrate some form of authentication that works in decentralized manner. In this case, data spaces works directly with the concept of self-sovereign identity. In this case, self-sovereign identity is basically more or less the way that we use our identification card that is issued by many countries. Okay, we have an issuer that could be, for example, the Spanish government. Give me my identification. We have a holder in this case. I am the holder, could store my identification in my wallet, and we have a verifier that is the people that need to check or verify if I am who I am telling that I am. And finally, we have this part that is the decentralized part, that is the verifiable data registry, in where all of the interaction have been stored and certified the authentication of the emission of the credential and also of the validation of this credential. What happened that despite this sounds very easy to understand, many of technologies are involved in this type of ecosystem because it's a decentralized ecosystem, not like we're using right now with Google, Facebook, or many other things that we authenticated using only one way of authentication. In this case, we need to include some complex things that Marcus and Dortmund introduced before, the IDs, verifiable credentials, verifiable presentations, and many other things that quite be very complex to introduce in this type of ecosystem, but more or less are covered in some ways in this type of ecosystem. The thing here is that in a data spaces there is some entity that is in charge to standardize the way that how you can join to a data space using a trust framework, okay? And this entity is called GaiaX. GaiaX is the entity that defines how you can join to the data space using the trust framework. In this case, the trust framework is more or less the same that we can see conceptually in self-sovereign identity, but they change some things in some way, and they don't use a pure approach. They use more things related to certificates instead of the DLTs, distributed ledger technologies, and many other things that they are changing. We are not very agree with this approach, and we are trying to see some solution for providing a better interaction and efficient interaction that relies on technology and not in political decision in some way. So in this case, GaiaX works directly with the European Commission, and all of these solutions are focused in the European market. So, for example, they are working very hard in trying to connect this with EIDAS 2.0, that is still ongoing work, but they are trying to connect these type of things. These have a disadvantage because they are very focused in the European market. But in this case, a necessity for open this market to different actors have been identified. In this case, actors for other countries that doesn't work with EIDAS, but can work with another type of authentication systems. That is why, in this case, we have been doing a lot of research for trying to provide in this case, in a low level, some protocols that could be adapted for join to different type of ecosystem and not only the Gaia-X ecosystem. The aim here is trying to open the data spaces approach to the rest of the world, not only Europe, and this could be implemented, or the thing that we take it from here is some examples and some approach that is similar to the verifiable credentials API from the W3C for providing this dynamic protocol, in this case in terms of authentication. I am going to go fast in this part because this is more complex and is not too focused in this part, because all of the topic of data spaces need some governance framework. Okay? The governance framework is very complex, is composed not only for access control, but also for data usage control, that is a research topic that is still open nowadays, and some of how we can consume this data with this type of topics. This is more or less how is the governance aspect that we have to cover. This was presented in some slides yesterday by Professor Salvatierra, and you can check it later if you want to know more about it. What happened that in data spaces, not only we have to focus in the authentication, that is the part in where we want to join to the data space, but also in the operation of how we can put the policies between different assets in data spaces. In this case, we are talking about authorization, how we can define some policies to apply to this data. For the part of the authorization, in data spaces, we have to be aware that we need to be focused in a zero trust architecture, because we have a decentralized architecture and we have to, in this case, secure all of the interaction between the different components inside of the data space. For this regard, we have relied on all of the part of the authorization in some concept that is called FGA. FGA is a fine-grained authorization. It's a new model that is, in this case, based on relationship-based access control, that is the approach that uses Google Drive for making permissions to the different folders. If I want to provide this permission to this folder, we are using, in this case, this model of authorization. The traditional models of authorization have been role-based access control, that is very usual. I put you in a role, you are an administrator, you can do some things, and you are a user, you can do something. You need to be associated with some role. Attribute-based is more fine-grained than role-based access control, but in this case with RBAC, that is relationship-based access control, we can cover these two other models. We can use RBAC and we can use attribute-based access control. So this is more dynamic, this is more adapted to the problems of data spaces, because we have many actors and many participants, and we need a very fine-grained definition of policies. So in this case, we use this approach for performing all of these things. The FGA approach is used by an open source software called OpenFGA. OpenFGA is a software that allows you to define policies using the RBAC model. You can integrate it to your solution, not only in data spaces, but in this case we use for defining the policies applied to data in a data space. OpenFGA combines the model of fine-grained authorization and also the model of zero trust. With zero trust, we have defined very complex things in some way that are very easy. For example, this is an example of how you can define some policies related to how a user can access to certain resource. And this schema has been chosen because in the data spaces, as Professor Salvatierra told yesterday, we are using ODRL to define all of these type of things. So the translation between ODRL to the language that is used in REBAC is more or less automatically. So this is why we have more or less some definition, as you can see in the slide, in the left part in ODRL, to the REBAC model for applying the policy in the right side of, in this case, the equivalence of the code. Finally, I am in the part of the protocol that we have been developed for providing this umbrella in data spaces for expanding the ecosystem, not only for GaiaX and Europe, but also for the rest of the entities or countries that want to join to this initiative. GNAP for verifiable presentation is the protocol that we have been defining. It is published in a conference in Louvain just in August. I forgot to put the link in the slides, but you can contact me and share the paper. This protocol is a combination between GNAP. GNAP is a modern implementation, or modern definition of OAuth 2. GNAP, in this case, rewrites all of the gaps that are in OAuth 2 and provide a modern solution with a more flexible environment to connect the current necessities that we have, in this case, in AI. So in this case, we have developed these flows that is a combination between GNAP and OIDC for verifiable presentation. We don't took all of the part of OIDC, but also only the part of the verifiable presentations. This is more or less a comparative between all of the gaps that we have in OAuth 2 and GNAP that basically doing the things for the current scenarios, and we have in this case the advantage that we can define dynamic and adaptable flows. That is the thing that we need to include in this case of data spaces. The thing here is that despite GNAP is very good and is a good reference or protocol defined, we need to work with OAuth 2 for the system that we are working right now. So in this case, GNAP for verifiable presentation also have the possibility to work in two ways. Proxy translation for receive requests directly from GNAP and translating to OAuth 2, or with a dual stack. We can put OAuth 2 and also GNAP for providing these two type of things. One of the key points of this protocol is that we have mixed and taken the best things of the both protocols. From GNAP, things like dynamic grant negotiation between different entities, and OIDC for verifiable presentation, for example, for selective disclosure. In this case, that is a very important thing that we need to include in data spaces, because we don't want to share all of our personal data, but we could make some verification, for example, only the age, only the address, or many other things, without revealing the other parts of the identification. Here are some pros and cons about OIDC for verifiable presentation, and with all of these cons, we are including some solutions that we using directly with GNAP and covering all of these gaps. Finally, the flows that we have identified has two ways. First, the wallet-driven interaction, that is an interaction that could be started by the human, ¿vale? And with this interaction, you can start to the process of authentication and retrieve the token that is the thing that you are going to use in the rest of interactions in the rest of operation inside of the data space. This is the flow, this is the chronograph. It's very difficult to follow in this way, so I am providing you some animation in this case for trying to understand in a better way how this works. So in this case, all of the requests have been started by the consumer. You have to know that the consumer has a wallet. In his wallet, they have a credential, and with this credential, the person or the entity start the flow. In this case, the consumer grants a request to the provider. The provider sends again a response, in this case, to the consumer. The consumer gives all the needed information that they have in his credential in the wallet. The wallet, through OIDC for verifiable presentation, goes again to the provider and performs some validations that in this case are presented in the GaiaX ecosystem. But this flow is not only centered in GaiaX. We can use different entities or trust frameworks to interact with this type of credential. In this case, we use only the components of GaiaX, but finally, we also have the possibility to perform some validation in a very pure self-sovereign identity form or with another trust, in this case, environment. Once this validation has been done, we have the wallet that make a callback to the consumer, and the consumer continue the request to the provider for finally retrieve the token that could be used by the consumer. This is a flow of interaction where we have, in this case, quit all of the bad parts in some way of OIDC, and we have simplified this way of interaction inside of this type of ecosystem. What happened that more or less the approach that we have right now is trying to integrate in the data spaces ecosystem all of the agents of AI for performing some task. In this way, we need to have some interaction or some flow of authentication that could be machine to machine. That is why we are not right now presented the Linked Verifiable Presentation authorization. That is the part that covers the machine-to-machine interaction without the interaction with a human. So this type of interaction could be started by an agent or by a component, and we avoid to use the direct interaction of the user. The interaction is similar to the other, but we need in that part uses some of, in this case, the ID server for providing all of this automation that we need to consider. For example, the consumer grants a request to the provider, and the provider goes, in this case, to a server to retrieve the DID, and then the provider also has the linked verifiable presentation that is associated to an DID document. So this is, as I know, is things that are very close to SSI, self-sovereign identity, and we need to perform the different validations to the different entities for being part or for being authorized to use, in this case, all of the things with the aim to, in this case, get the token to start the interaction between different actors in the data space. Where we here have a demo about this interaction. As you will see, all of the part of the flow is skipped because it's transparent to the user. You only need to use some request, put it in your wallet, this link, and then you can make the presentation needed for this type of environment. Could you please? Okay, this is very, very fast because we only make a request with some parameters. We retrieve the URL where we want to present our credential. we put this link in our wallet. This wallet could make the presentation to the provider. And finally, when we validate this presentation, we have the token. So all of the things that I have been talking in these 30 minutes basically is resumed in this part. We have a flow that we have been defined for different actors, for a different ecosystem, and we retrieve a token that could be used in the rest of interaction that could be also used, for example, in all of the part of the agentic. In this case, agentic in data spaces. Because, as I have been talking since the beginning of the presentation, data spaces could be a little complex, and some of the operations need to be automatized. In this case, for automatize all of these things, we think that the correct approach is using AI agents to perform this task and avoid all of these type of things. This basically lead us to have some part of the identity for the agents to be part of the data spaces. This is why we need to also use all of the self-sovereign identity ecosystem, but in this case, including all of the part of the agents. And for the flow of authentication and validation, we can use the protocol that we have presented before, that is GNAP for verifiable presentations. The aim here is that a data space or a member in the data space could use all of the automatic or dynamic way that use through agents for, in this case, provide some data transfer or data service to different consumers. In the example in the slide, we are using some of the healthcare data space in where some people need to be authenticated and only can see some part of the, in this case, analytical result of a patient. In this case, in data spaces, we need a multi-agent collaboration. This is why we need to define some of interaction that could be in automatic way. And some of the vision that we have right now about data spaces and AI is basically summarized in this slide. We have 4 levels of integration of agentic AI in the data spaces, but right now we are only in the point number 2. We are not still in the interactive part of the data spaces where we can put something and the agent performs some task. But in this case, we are only in the predictive part of this data space. As a conclusion, in this case, all of the self-sovereign identity and trust is crucial in this case for secure the data spaces. Agentic AI has been presented as a new actor in this case for data spaces for simplify all of the complex thing in data spaces. We have also authentication, authorization that we can perform in a machine-to-machine way. And also, it's important to have a human and AI collaboration for performing all of these tasks in data spaces. As a future work that we have been developed in the last months, we want to provide some scalability and some validations and some metrics about how we can scale, in this case, using agentic AI for performing this task. Also, all of the governance part is another work that we have to put it inside of this ecosystem, but we are, in this case, preparing all of the pipes for integrating this part inside of the ecosystem. All of the interoperability is needed to be included not only for Gaia-X, EPSI, but using a global standard like the W3C. And, well, the vision is trying to go further, in this case, of the current implementation of data spaces and expanded this part in this ecosystem. Thank you.